Nuhu is evaluating different investment options and wants to understand how the interest rate affects the growth of his savings. He's considering two options, one with annual compounding and one with quarterly compounding. He's also looking at the time it would take for his investment to double at a given interest rate. Required, Nuhu invests in a savings account offering a nominal interest rate of 8% compounded quarterly. What is the effective annual rate for this investment? So with this, since the interest rate is being compounded quarterly, so it's spread out through the year. Okay, that 8% is spread out through the year. So the effective annual interest rate just converts this quarterly compounding into an annual compound. Just gives you this is your total interest rate for the this is your total interest for the year. Okay. So again, here's the formula: effective annual interest rate 1 plus the nominal rate divided by the number of compoundings raised to the number of compoundings. So 1 plus 0.08 over 4 raised to the power of 4 minus 1. Okay, once we do our tabulations, we're trying to find the effective annual interest rate for interest that is compounded quarterly. This interest that's being compounded quarterly, you just want to convert it into an annual rate now. Here's the question. So since it's compounded quarterly, want to find it, want to convert it now into an annual rate. Ze- 0.08 divided by 4, that is 0.02. And you do 1.1 plus 0.02 to the power 4, you get 1.082432. Subtract that from 1, you get 0.0824 or 8.242%. So basically, this interest that was compounded annually, if you convert that rate into an annual rate, a yearly rate, it's on 8.2. So this is the total interest that you earn in that year. In simple words, the total interest that you're going to earn that year will be 8.24. Okay, so to find how long it would take 10,000 to double at an annual interest rate. Okay, so as I said, you can use the simple formula rule 72. Okay, where you just say 72 divided by the rate of 8 years. 72 divided by 8, it will take basically 9 years. Okay, but in this question, as I said, this is just for your general knowledge. Never use this in the exam. Let me get that formula here. Yes. So if you remember in the other video, if you want to find how long it will take, we use this formula here. This is derived from the future value formula. Okay. You remember how we derived this equation last time, right? hmm So you get the log future value. Since it's a 10,000 and want it double, so that would be 20. The future value is 20,000 over present value 10,000 divided by the log of 1 plus 0.08. So it's going to be log 10,000 divided by 20,000 divided by 10,000, that is 2. 1 plus 0.08, that is 1.08. Log 2 divided by log 0.08. So log 2 is 0.301. Log 1.08 is 0.03, 0.033. So 0.301 divided by 0.033, you get 9.12, which is 9 years. Nuhu is considering a 5-year investment and wants to determine the interest rate required to grow his 15,000 to 20,000. What is the required interest rate? Here again, let me just show you how that formula is derived. Future value equals present value 1 plus the rate, the power n. And here want to get, so want to make r the subject of the formula. So first we divide out the present value. So 1 plus r the power n equals the future value over the present value. We need to get rid of this n. So the way we get rid of this n, I'm going to multiply it by the reciprocal. So we raise this to the power 1 over n. And what you do on the left hand side, you do on the right hand side. Raised to the power 1 over n. Therefore, n times 1 over n, the n's cancel each other out. So remain with 1 plus the rate equals the future value over the present value raised to the power 1 over n. So we're trying to make r the subject of the formula. So this 1 crosses over and it becomes here. So to get the rate is the future value over the present value raised to the power 1 over n minus 1, which is here. Future value 20,000, present value 15,000, n 5. So you do 20,000 divided by 15,000 raised to the power 1 over 5 minus 1. And when you do your tabulations, you get a rate of 5.95%. So in your calculator, when you're raising to, better you convert this fraction into a base, okay, to be on the safe side. So 1 over 5 is the same as 0.2. So you can also raise it to 0.2. Any questions?